going to take a look at is frequency and histograms. This is a way to get started in looking at distribution of data and looking to see where most of our numbers are coming from, and it's oftentimes presented in a way that is very close to a bar graph. One skill that we're going to need to have before we get going with this is finding least and greatest numbers, as well as being able to organize a data set from least to greatest so that we can break these data sets into equal groups. So what I want you to do right now is I want you to pause this video and organize and do this warm-up so we get the least and greatest numbers as well as order from least to greatest. I'll put the answers up here in a second. Alright, here are your answers. Notice how down in 3 and 4, I made sure that after I ordered my numbers from least to greatest, I had everything checked off on that list. This is a good way to make sure that you are getting all of your numbers. Another quick way to double check is to count all how many numbers you have in your first set and count how many numbers you have in your second set, and they obviously should match up. This way you are going to be able to avoid making any silly mistakes. So for example here, I have 1, 2, 3, 4, 5, 6, 7 numbers. And my final set, I should make sure I also have 7 numbers. This is just a quick way to double check to make sure you didn't get anything wrong. 1, 2, 3, 4, 5, 6, 7. Now that means I know I had the same amount of numbers in the first set and the second set, which means I probably put myself in a position to get this question right. Moving forward. Okay, now what we're going to do is we're just going to take a little bit of a look at reviewing for reading bar graphs and circle graphs, some stuff we've already done before quite a bit. Let's take a look right away at the first example. We have a graph. Now, whenever we're reading graphs, the most important thing we need to do is make sure we're looking at scale as well as the labels on the axis. All right. So, for example, here we have a title up here. Lifespan of various sharks. Very, very important. We also have our labels on both our axes. We have years, which would be how long those sharks are living. And over here we also have the different categories of sharks. Okay, those are the most important facts for us to be able to even read this graph correctly. So now we can be an educated observer. We take a look at the first question. It says, use the bar, which shark lived longer than any other shark? So again, depending on what this graph might show on the axis as well as the title, we need to make sure we're reading this correctly. Because this says which shark lived longer, we're going to take a look at our axis indicating years. We're going to see that going this way is longer in years, so we're just looking for the bar that's biggest that way. And in this case, it looks like our largest bar is right here, which corresponds to whale shark. Second question. About how long did the basking shark live? Well, again, basking shark is right there. We take a look at his bar. We see it go out to roughly this line. This question says about, so I'm not going to be super picky. It looks like it's a little bit past 30. If you really wanted to get into doing the math, there looks like there's 5 bars between the 30 and the 40, which means because there is a difference of 10 between 40 and 30, we have a set of 10 years here, and a fifth of 10 years is 2 years. So because that bar goes 1 notch out past the 30, that would be about 32 years. Third question, which shark lived about 1/3 as long as a dusky shark? Well, in order to answer this question, we first need to figure out exactly what's going on with the dusky shark. I'm going to erase these marks I have up here. Dusky shark looks like it goes right there. And that looks like it's all the way up to 30 years. Well, if we just stop thinking about this, we're looking for a shark that lives about 1/3 of the dusky shark. And we know that dusky shark lives 30 years, which means 1/3 of 30, of means times, 1/3 of 30 is simply 10. Well, if we're looking at these bars, we can even just picture it visually and look at how big this bar is And which one might be roughly a third of that? Well, the only thing that looks like might even be possible is right here, the hound shark. If we take a look, the hound shark goes out to 10 years, which means 1/3 of 30 is 10. And it looks like our answer, this last question, is hound shark. Moving on from bar graphs to circle graphs. Okay. Now, instead of looking at sharks, again, the most important thing is to look at labels, axis, titles, all that fun stuff. In this case, our title's right here, ice cream orders. That's the most important thing for us. We also see each one of these different slivers of this circle graph labeled. We have strawberry, ice cream, vanilla, chocolate, peanut butter, and mint chip. Looking at first question, there were 5 times the number of orders for blank as there were for strawberry. Well, to answer this question, we need to take a look at strawberry. It looks like there were 2 orders for strawberry ice cream. Well, if we're looking for something that's 5 times as big as that, 5 times 2 is 10. We see that chocolate has exactly 10 orders. So, because 2 times 5 is 10, 5 times as many as strawberry, we know that this would be chocolate. Last question is a little tricky. What percent of the orders for ice cream were mint chip or vanilla? Well, let's see here. We haven't talked a lot about statistics, but or means we can accept either one. If I say that I would eat ice cream if it were mint chip or vanilla, and I randomly pick some of this ice cream, I would know that I would accept either mint chip or vanilla. So really what or means in terms of statistics is adding. So what I'm going to do is I'm going to add my mint chip and my vanilla together. Looks like I have 11 mint chip and I have 19 vanilla, which means out of the possible ice cream orders, there were 30 of them that were mint chip or vanilla. Well, because I'm looking for percent is a number, a fraction or a number representing a part of a whole. Well, the whole would be how many total ice cream orders there were total. So we have not only our mint chip and our vanilla, but we also have our strawberry, we also have our peanut butter, and we also have our chocolate. Well, if I add all those together, I get 50. Now, this is a fraction, not a percent, but that's all right because it's very easy to go from one to the other. First of all, if I have 30 over 50, it's very easy to take a 10 on the top and the bottom by simply crossing out the zeros. 30 divided by 10 is 3. 50 divided by 10 is 5. 3/5 is one of those fractions that we should be able to recognize as a percent right away. If I were to take 3 divided by 5, I'm going to get 0.6, which is our answer is decimal. But what we're really looking for is that as a percent. To go from a decimal to percent, again, we take this and we move our decimal place twice because percent is a fraction out of 100. 60%. Looks like I'm fairly easy to please. All right, now that we've refreshed a little bit about what we know about graphs and reading graphs, we're going to actually get into our frequency and our histograms. Okay. Again, this is another way we are going to organize our data so we can kind of start to see distribution, where the numbers are located, who has bigger numbers, who has smaller numbers, stuff like that. So, first question. We have the number of rushing yards completed by a running back in a professional football team in each of the 16 regular season games is given. Use the data to make a stem and leaf plot with the title and the key. Very, very important. We already talked about this. Title, axis, everything that kind of tells us what's going on about the graph is the most important part. So, very easily, I already have a table here which has all my information on it. So what I'm going to do is I'm going to start making the stem and leaf plot over here. Well, the title for my graph, for my table was rushing yards, and I know that this is the same thing, so I'm simply just going to rename this rushing yards. Now, I'm making a stem and leaf plot. Stems are numbers that are representing a larger place value than our leaves. In this case, because our rushing yards are ranging, it looks like our smallest number is 32, And it looks like our largest number is 98. It looks like because we have the biggest digit being the tens place, that's what we're going to use for our stem. With that being said, our smallest stem, our small tens place, is a 3, right there in that 32. So that's actually going to be my smallest stem. 3 is going to represent 3 in the tens place, which actually represents numbers in the 30s. Well, not only do I have numbers in the 30s, I also have numbers in the 40s, 50s, 60s, 70s, 80s, all the way up to 90s. So what I'm going to do is I'm going to make stems for each one of those. 30s, 40s, 50s, 60s, 70s, 80s, 90s. Great. Now, what I'm going to do is I'm going to actually fill in the stem and leaf plot. To do this, I'm going to look for all of my numbers that have a stem of 3. In this case, it looks like it's just 32. I am going to start with my smallest leaf, and I'm going to work my way out. But in this case, because there's only one leaf, I'm just going to start with 2 right here. Now, again, that stem is the tens place, that leaf is the twos place. To make sure that we recognize that later on, what we do need to have is this key. A key is just something that's telling me I have a 3 in my stems, in my stem spot, I have a 2 in my leaf spot, but I don't know what that number represents. It could represent 32, it could represent 3.2, it could represent 302, it could even represent 3,000,002. So what I need to do is I need to write a key. 3 with the bar and a 2, it actually means 32. So great, I've got my title taken care of, I've got my key taken care of, and I've started making my stem and leaf plot. After looking at a stem of 3, I'm going to take a look at a stem of 4. The numbers that have a stem of 4, so I'm also going to cross the 32 out to make sure that I don't accidentally reuse that or forget that I have it taken care of. It looks like I have a 43 right there. I have a 48 right there. And that looks like all I have for my 40 stems. Well, again, I'm going to start with my smallest leaf, 3. That 3 there actually represents a stem of 4, a leaf of 3, 43. My next was 8. Now that I have my 2 leaves taken care of with a stem of 4, I can cross those guys out, move right on to the next one. 5s. Looks like I have 52, 57, 54, 54. Again, I'm going to go from smallest to biggest. So my smallest leaf was 2, then I had a 4, then I had a 4, then I had a 7. Again, cross those out. I have taken care of my stem of 5. Next, stem 6. I have 65, 68, and that's it. My smallest was 65, my biggest was 68. I'm just going from least to greatest in there. Gone, gone. Next, stem of 7. 78, 72, 73, 74. Smallest was 72, then 73, then 74, then 78. Stem of 8. I have 83, and that looks like it's it. And finally, stem of 9. I have 98 and 96. 6, 8, I am done. So there is my stem and leaf plot. Again, we are starting to see kind of where the distribution is. It looks like most of our numbers are falling in this 50 to 70 range. We can see that because there's only one leaf up here, and there's only a couple leaves down here. So we can see kind of where the meat of our distribution is. Now that we've talked a little bit about making these stem and leaf plots, we can go ahead and talk a little bit about reading them. Well, specifically in this case, we actually have a double stem and leaf plot, meaning not only do I have one person's or one group's data, I also have a second group's data. In this case, it said the test scores for 2 algebra classes are shown in the stem and leaf plot. I obviously have 2 different classes, so there are going to be 2 different types of grades. Let's answer some questions. Again, most important thing is to look at our titles, period 5, period 3, which means all the numbers on this half are represented by our 3rd period, and this half are represented by our 5th period. We also have a key with a number in the middle and a number on the outside, and what that represents. It looks like our stem is taking place in the 10th spot. Our leaf is taking care of the 1 spot, which is why the 6 with the bar and the 8 means 68, and the 8 with the bar and the 3 means 83. So, reading the first question, how many students scored 100%? Well, if I'm scoring 100%, I have a 10 in the tens place, which means I have a stem of 10. And it looks like there are only 2 people that happen to both be from period 3. So I actually have 2 people. B, how many students in period 5 scored greater than 80%? Well, if I take a look at period 5 over here again, and we are looking for greater than 80%. 80% would mean I have a stem of 8 with a 0 after it, or anything bigger. Well, if I take a look, switch up colors here, I have 1, 2, 3, 4, 5. An 83, an 88, a 91, a 93, and a 99. Looks like I have 5 greater than 80. C, what was the lowest score in period 3? Well, again, it's easy because all I need to do is drop right down the stem column. See that my smallest stem is a 5, and the smallest number that corresponds with that stem, the smallest leaf that corresponds with that stem is a 3. So the lowest score in period 3, which again is the right side, is a stem of 5 and a leaf of 3, or a 53%. Which period had more scores? Well, I'm going to erase all this just so we can kind of take a little bit better look. Again, each leaf is representing one different data point, one actual score. So all I need to do is count my leaves up on both sides. My period 5, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 leaves, which means I have 16 different scores. Period 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 different leaves, which means I have 15 different scores. Period 5 has more scores. And how many more? They have 1 more score. Great. Moving on. All right, now we're going to get into the new stuff a little bit. Okay, what we're going to be doing is we're going to be looking at frequency tables and histograms. Again, this is a very similar way to creating a bar graph. However, instead of just having a categorical data, we're going to have ranges of data, kind of like what we saw in a stem and leaf plot. A stem had all the numbers that had the same tens place kind of put out the side. So actually, if we take a stem and leaf plot, we turn it on the side, it almost looks like a histogram. But let me show you exactly what I'm talking about. Well, here we have the number of calls per day to a fire and rescue service for 3 weeks is given below. Use the data to complete the frequency table. So all I'm going to do is I'm going to take a look, and over here at my frequency table, it says number of calls, and it has different ranges. So all I'm going to need to do is quickly count up how many I have in each of those ranges. And again, once I have that done, I'm going to double check by making sure I cross off all my numbers over here. So quick pause this and fill that table out. Great, now that we have a frequency for everything and we have double checked to make sure we have all 21 over here. I have 21 crosses over here. I add up all these numbers. I get to 21. I made sure I didn't miss anything. Question 4 says to use the frequency table in exercise 3 to make a histogram with the title and axis labels. Luckily for us, that most important part, that title and that label, has already been taken care of. We already have the title of Fire and Rescue Service, and we have labels on the axis as both frequency and number of calls. Now the big difference between a histogram and a bar graph is, again, we have a range of data in each bar rather than just a category. The other important thing to recognize is that these ranges, all these ranges, contain the same amount of numbers. 0 to 3, that means it could be a 0, 1, 2, or 3. 4 numbers. 4 to 7, it could be 4, 5, 6, 7, 4 numbers. 8 to 11, it could be 8, 9, 10, 11, 4 numbers. And you get the point. We need to make sure that these are even for everything. Now, once they are even, that also means that when we make our bar graph, our bars need to be roughly the same size. The main difference between a histogram and a bar graph is that the histogram, all of our bars are going to touch. So let me show you. Our first group had between 0 and 3. So what I'm going to do is I'm going to put between 0 and 3 here. And the number of calls happening in a day between 0 and 3 happens 6 times. So my bar is going to go all the way up to 6. Next group was 4 to 7. I know my next bars actually represent how many times I got 4 to 7 calls. That frequency was only 4, so I'm going to go over, down. Next group, 8 to 11. That had a frequency of 4. Next group, 12 to 15. Had a frequency of 3. And last group, 16 to 19. Had a frequency of 4. There's my histogram. Notice all my bars are touching. They are all the same distance apart, and they are all representing ranges that contain the same amount of numbers. Lastly, which intervals have the same amount of frequency? That's pretty easy. It looks like if I just go straight across here at 4, I have the range 4 to 7. Let's try that again. 4 to 7. I have the range 8 to 11. And I have the range 16 to 19. All with a frequency of 4. Awesome. Great. Now that we know how to do all this, let's go ahead and take a look at one and practice it. So what I'm going to do is I want you to pause this right now. I want you to go ahead and do this example. And once you're done pausing and finishing, I want you to come back here in a couple seconds and check your answers. This is what I got for answers. Tallest plant was from group A. You see it right here. And it also looked like we got twice as much sunlight in group A because their heights are about twice as much. Moving on. Oops, backwards. That's not what I wanted to do. Moving on. Here's another one. We're making a stem and leaf plot. We're actually making a double stem and leaf plot. We already went over how to do this. So again, the key points to remember are to have a title, to have labels, to have a key, and to make sure we are working from the inside out, smallest stem, this means smallest leaf to largest leaf, and that we make sure we don't skip over any stems. So what I want you to do right now is pause this and do this one on your own. You can check your answers back here in a second. All right, here are my answers. Again, I double-checked everything by crossing off the numbers as I went. I also double-checked at the end. I counted how many leaves I had for both player A and player B, and then counted to make sure that that added up to 16 because that was how many games were played. Good, moving on. Again, we've had a little bit of experience talking about frequencies. So what I'm going to do is I'm going to have you pause this right now and do this on your own. I need you to remember that when we are breaking these intervals up, those intervals need to be the same size. Those intervals need to be the same size. And it's hard to do this sometimes because when you're making a range, if I have 10 to 15, that's not just 5 numbers. That's 10, 11, 12, 13, 14, 15. That's 6 numbers. So I need you to be careful when you're making a range in order for you to make a frequency. I also want you to make sure that we are breaking this down in as many pieces as we can. If I take a quick look at the number of calls, I have all the way down from, let's see here, 13, 12 is my smallest, all the way up to 26. Well, 26 minus 12 is 14. And I know I have 5 different categories to break it into. So if I broke those into groupings of 3 numbers, that'd probably work out the best for me. And I need to start with 12. So 12, 3 numbers past 12, 12, 13, 14, 12 to 14. That is what I would do for my first range. And I would continue the table from there. Pause this, fill out the rest. Now, one thing we have not talked about, actually, after you check your answers, is cumulative frequency. Well, the word cumulative means if you add them all up. So what I'm going to do is I am going to start with my first table having a group of 5 because that was what my frequency was. And then my next one would actually be my range from 12 to 14 plus my range from 15 to 17. In this case, 5 plus 4, 9. And again, cumulative means we keep adding on. So if I add the next row, it'll be another 4, 13, and another 7, 20, and another 1, 21. That's what we're talking about with cumulative frequency. Great. Well, now that we have that frequency table, it's going to be super easy for us to make a histogram. I want you to quick pause this, make a histogram, and check your answers back here in a second. And there you have it. Again, we need to make sure that our bars are touching each other, our ranges are all the same. Make sure we have our title and our labels, and we're good to go. Great. Now you guys should be experts on histograms or frequency tables. I want you to go ahead and practice with 10-2 practice C and 10-2 problem solving. This should be in your packet you got from class or on your online website. You will check your answers back. They will be posted. There we go. There's frequency tables and histograms.